Hey, Trevor, thanks so much. And thank you everyone for joining this amazing NODES2022. I'm really privileged to speak with you today about data loading best practices. So first question you're probably asking is why I would give such a talk. And I haven't been with Neo4j for that long. And after the first month, I was asked to write a Neo4j Flex template for Google DataFlow Apache Beam. And my first reaction was something like this. And so I, surveyed the organization and said, how is it, guys, that we should do this? What are the best practices? Materially, how can I avoid face planting? And captured some information that I applied to that project, and am sharing that information today with you, so that if you try to do something similar, there's no fear. All right, so let's get going. First off, who's my audience? So I've addressed this talk to Neo4j developers, anyone out there. You might be working alone with a company, you might be developing a solution for a partner. You might be working at an ETL or ELT company and trying to figure out how to support Neo4j. So welcome all of you who are here and or catching this on video. Thanks again for your time. So the high level agenda will be to talk about the domain, ETL, to provide some examples of commercial applications that are out there, to talk about the basic method that is used for loading Neo4j, and it's really not that hard. And then a deeper dive into some of the ancillary topics that we bring up during that discussion. If there's time, we'll do some QA afterwards. All right. So what are the end user benefits for ETL and ELT? And that is configuration versus code. So it's obviously a shorter learning curve, point and click. Often you might have a more simple interface. In some cases, it could be a JSON file, or it could be command lines, or it could be a full UI, and we'll show examples of those. For the end user, fewer errors, faster time to value, and so forth. It's good for everyone. And the reason it's easier for the end user is because you're doing the heavy lifting for them. So everyone here, I would expect, would know the difference between ETL and ELT. With ETL, the transformations are happening before they hit the Neo4j database. And with ELT, the transformations are happening afterwards. And that can be, the ELT paradigm seems to be more popular, requires less memory and processing on the engine itself, and pushes those back to Neo4j. The challenge there is one of managing the workflow, and you might be pushing non-final artifacts into Neo4j and then fixing them up afterwards. But as part of an analytic workflow, that might be what you want. In fact, you might want to kind of blow away the database, create a new one, load data, do transformations, do GDS projections, write the data perhaps back to the graph database, and then export that data out, and then shut it down again. So in that case, your entire analytic workflow looks a bit more like ELT than it does ETL. Either way, I hope you can apply some of the tips here presented here to what you're trying to do. So there are three high-level approaches to data loading, if you will, the state of the art. The first one is a native bulk load, and customers tend to use Neo4j admin to do that. It runs locally on local files. It creates new databases. The database, at least for some portion of that process, has to be down. It's not enforcing all the rules and observing ACID compliance during the load, and it's very fast. Now that's a local load. Now there's a second approach with GDS Enterprise that has been recently released, and that uses the Apache Arrow flight protocol. So check out Dave Attila's Road to Node presentation. He gives 2 hours of love on this topic, really does just a fantastic job. And it is a similar speed, also very fast, on the order of 1 million records per second, reading and writing. Actually, that's reading and writing into the GDS in memory graph. Now, what we're talking about today is not that. We're talking about real-time transaction pipelines, which likewise are remotable. In other words, you have a client on one machine and the server on another machine. The process is ACID compliant, and we have at Neo4j terrific language support, lots of APIs. Notably, not all the APIs perform the same. The call out that I mentioned here today is that reads on Python are a little slower than an order of magnitude than on Java, for example. So in terms of performance, what to expect? Around 15,000 to 40,000 records per second. And that depends on the size of the records. It does not depend on the size of your cluster. All writes are going through the leader node at that time, and then they're being committed and replicated, committed to followers and replicated to read replicas. So, so that's it. That's what you're going to get using the Bolt protocol, and that's what we're going to describe today. So the building blocks are our APIs, our SDKs, and supported in all of these languages. The most common I've seen are Java and Python, but we support Go, Spring, and .NET and JavaScript. There are other community supported APIs out there that you can use. Now, what ETLs exist in the marketplace today? So Apache HOP is sort of the one we use and recommend most commonly here at Neo4j. It's maintained by an open source community led by Matt Casters, who works here. It's very full featured. It's a sort of a redo of Apache Kettle, which was a well-received application. A bit similar to Talend at the bottom of the list, in that a large breadth of features, and the developers have taken the time to build adapters for Neo, which is terrific, using best practices. GraphAware Hume is a full lifecycle workbench for Neo4j, terrific app. Check it out if you haven't already. And they do have an ETL built in called Orchestra. It's very flexible. I believe it's based on Apache Camel. High marks for those guys. The ETL tool that comes with browser, desktop, great for getting started. Nice modeling UI, source target mapping, JSON metadata export. Highly recommended for getting started, but for production workflows where you have repeatable flows, updates, and so forth, it's not going to help you much. The Apache Beam DataFlow implementation, now in kind of beta, and there, you can Google it. I wrote that one, so challenges are on me. Really neat JSON configuration, includes the ability to do Cypher before and after. We, for a number of years, have been supporting Spark with the Spark connector and various APIs. You can, it is an opinionated framework. It does a lot of things under the covers for you, batching and orchestration described here. It's a coding exercise, but very flexible, great for analytic workflows. It does require a Spark runtime. The Neo4j admin import, as discussed, is just a super fast pipe for blasting data into Neo4j. So enjoy it, but don't expect too much from it in terms of end-to-end pipeline, and certainly no transformations after load and so forth. So just a quick visual in case you've never seen Apache HOP. This is what the UI looks like. There are various skins and so forth. This one being the dark one. A few interesting points. So Matt's built support for streaming engines into the thing, so you don't necessarily need to run the job on the machine on which HOP is installed. Now, this doesn't support the entirety of the transformations you can do in the product, but the little widgets are marked to tell you whether they support exporting the job to one of those other platforms to run in parallel at scale. Very cool. The Apache Beam DataFlow sort of flex template. This is what a completed job looks like. And what you'll see here is an orchestration that starts with parallel node loads, some blocking, and then throttled insert of edges afterwards. And we'll talk about why that's significant in a moment. Graph-aware Hume, the UI looks a bit similar. This is the designer UI, sort of that full-featured flow type UI you're accustomed to from Alteryx or Informatica and so forth. Just a quick note, question, why don't we see Neo4j support in every ETL tool out there? I think there are a few reasons. So most often, big customers drive adoption, and today, Neo4j started out as a developer tool. Our customers are very smart, and they tend to roll their own APIs. So they're not demanding that they show up in enterprise workflows, but that is changing. So I can't share the names of all the companies that have expressed interest, but quite a few, and we're working with several right now, hopefully more listening in on this call. Graph database is extremely important, why we all love working here and using the product, but small compared to a relational database market. And finally, it's a little more difficult, perhaps the reason why we're doing this talk, to load data into Neo4j than a relational database. Much of the loader work that happens with a relational database can be shared across many of them because there are standard ODBC, JDBC interfaces. They can use SQL as a standard. There are standard approaches to bulk transactions, to relaxing constraints, and it's a bit different here. Specifically, and obviously, edges you can think of as a mandatory equi-join where constraints can't be relaxed during insert. So when we commit our source and target bound edge on write, we don't have to pay for that expense on read. So the fundamental difference in graph native storage causes a change in how you load the database. So if you get anything from this presentation, I'd like you to mentally screen capture this page. The basic method for loading Neo4j is to create all your indexes and constraints first, to load your nodes, and then afterwards load your relationships. And when you load your nodes, you're going to be able to load them in parallel. Important to keep in mind that we're going to be processing each transaction on a single core or hyperthread. So when you set up parallelization, be mindful that if you parallelize too many threads, they're going to queue. So up to the number of cores or really hyperthreads in the Neo4j cluster. Use create. If your database is empty, it'll be faster. Use merge otherwise, and make sure that when you're merging, you're looking up keys that are indexed for obvious reasons. Beware of the null. There are no nulls in the Neo4j database. It's schemaless, and nulls represent the absence of a property. But sometimes the source is going to have a property which you can't drop out. It's not efficient to drop out. So you're going to want to coalesce that into a non-null value. Also be mindful of batching. It's very inefficient to create a cipher statement per record when you're loading Neo4j. Do use Unwind, and a good batch size is 5,000 records. Certainly something greater than 1,000 is going to increase efficiency. You can't batch too big because materially in a clustered environment, there's a hard limit of two 2 gigs of sort of transfer of a hard get limit for a commit to transfer that data between nodes. So, you know, if you get up to 100,000 or whatnot, you might end up, depending on the size of the records, hitting those constraints. And there's marginal benefit in making super huge commits. When you load relationships, be wary that the relationship creation is a blocking transaction. We're going to obtain exclusive locks on the source and the target. So if you have an application that has multiple microservices or threads that don't know about one another, they could be simultaneously creating relationships on the same source and target nodes. Those could queue, deadlock, timeout, or fail. You're going to need to handle that in your code. And now, in some cases, you know that the simultaneous relationship inserts or merges don't affect the same source and target nodes at the same time. So in that case, you know, feel free to parallelize your load. And you know, in the hop example, this is how you might think of it. So Matt demos a flow where he pings Neo4j, checks that we're alive, then he creates indexes, creates constraints, and then gets a handle to the input data, loads the nodes, loads the relationships, and then secondary relationships. So that's kind of it. That's the overall flow. The rest, as they say, is commentary. And we have written that up in a manual called the Neo4j Integration Cookbook. This is a public link. It will be available in the slides when we're finished here. All right. So the rest of your time, feel free to take somewhere else. I'm kind of kidding. There's a little more detail, but that's the gist of it. So we're going to talk a bit more about indexes, transactions, locks, labels, parallelism, unwind, null values, data types, apoc, and a few other things. All right. So if you're coming from the relational world, you're accustomed to data types like a primary key type sometimes. That doesn't exist in Neo4j natively. So without constraints, will create duplicate nodes and relationships. So you could create SAM 100 times inadvertently if the word SAM was not on a uniquely constrained property. So also, you can imagine if I'm doing an upsert, a merge, it's going to be slow if that key field that I'm merging on is not indexed. We're going to be doing table scans like our poor old RDBMS cousins. So do create indexes first before any flow that uses them. And the types of indexes you can create depend on whether you have the community edition or the enterprise edition. Your enterprise edition purchases, thank you, pay the bills here. There are a few kinds of constraints that they offer exclusively. So you do get individual property node constraints, uniqueness with community edition. With enterprise, you get property constraints, you get relationship property existence constraints, and multi-property key constraints as well. Now about transactions. So if you just issue a Cypher query in browser, for instance, or Cypher shell, Neo4j will wrap that in a transaction implicitly. That entire operation is held in memory until the transaction is committed, and then it'll be persisted to disk when it's visible to other transactions. So this is what we call read committed isolation. If an error occurs either during that query evaluation, the transaction will be rolled back and no changes will be persisted to the graph. So that's keeping our ACID promise. Now, in addition to implicit transactions, and we'll get into that a little bit more later, you can also create transactions explicitly in your API code when you create sessions and you create transactions. you can use the show transaction cipher command to see the transactions that are running. And in terms of sort of resource workload loading, if you do have read replicas, you're going to want to try to direct your read transactions towards them. And with the new version 5, some of that happens behind the scenes. But keep your write transactions pinned to your primary or your core nodes where they're going to be routed anyway. So, but you don't need a core node to do a read transaction, obviously. Now, about transactions, so they, in a clustered system, they get created on the leader, and then it commits to a log on at least half of the nodes. So, when you're deploying your Neo4j cluster, you're going up from 1 unclustered to 3 to 5 to 7 and so forth. And we'll want to commit that log to a majority of the cluster before we accept it. And if there's no quorum for that, we'll reject the commit and tell you there was a problem. As mentioned before, there is a bit of a limit for an individual transaction, as you replicate it around the cluster. So, that accounts for some of the hard limits around batch size that, good to keep in mind. Transactions will by default wait indefinitely, and so you might want to set acquisition timeouts, and you can set global timeouts for the runtime of the transaction as well. Those things in red are configurations in the Neo4j conf, and I urge you to dig deeper into the documentation for more information about that. So this is not our chart. This is, somewhere on the internet, a chart of the types of transactions that you're probably familiar with. By default, Neo4j is running read committed transactions. They're shared, and that's the fallback write behavior if we can't determine whether you actually need an exclusive or serializable lock. So that being the sort of most strict serialization where nobody can read while you're writing, or no two threads can write at the same time. Serializable, you can think of that when you see in our documentation something called exclusive write locks. And we're going to talk in a minute about how you can also create exclusive write locks using the underscore lock idiom in your code. So I sort of rushed over the idea that, we create locks implicitly. So what does that mean? So there are certain types of operations where we have enough information to create exclusive locks for sure, and we do. So when you're adding or removing a property on a node or relationship, we will exclusively lock that node or relationship. When you're creating or deleting a node, a write lock will be taken for that node. When you're creating or deleting a relationship, a write lock will be taken on the relationship and both the source and the target of that relationship. So locks are added implicitly, when the transaction is created and then when it finishes. Now, you're probably asking, what happens when you have a node with 1 million followers? So if Elon Musk exists in the Twitter network, how do we handle that? And in version 4.3 Enterprise Edition or later, we actually treat those records in the underlying file system as a set of records, a group, if you will, rather than one. So we're going to be locking on a piece of that supernode rather than on all of it. So that increases throughput on supernode writes, updates, merges, and creates for relationships a lot better. Now, what are the exceptions? So In the case we can't figure out whether to create an exclusive lock on a node, what do we do? So we'll fall back to read committed isolation. Now, if you look at the example here where you're incrementing a property on a node, Neo4j is going to be able to figure out the simple case. But, and this is arbitrary, if things get complicated, we will bail, and that won't always give you what you want in terms of isolation. So we recommend in that case to use the lock idiom. It's kind of an inferred property, and as I understand it, this isn't yet part of the Cypher spec or isn't implemented any other way at the moment. But you set this inferred property on the node to true, this underscore lock property, and then you remove it at the end of the transaction. Now about labels. Labels are kind of an interesting thing in the label property graph. We support many of them, technically infinitely, but we don't recommend more than 4. A label is a way to discriminate a node. So for instance, by tenancy, or if you want some kind of admin function, in addition to, its domain usage, the typical, as in this case, shown as user. It's kind of like a super index, and it's very efficient for performance, for sort of partitioning your data internally. It's a very important structure. We just don't recommend that you overuse it, please. In terms of parallelization, I've talked about the need when you're updating Neo4j to orchestrate, and that is because we're not committing siloed individual pieces of data into Neo4j unless we're creating, say, a new node. Our data is stored in a connected fashion. So you can parallelize reads, all good, parallelize node writes, all good. When they're being created, they're being created individually. You're typically not having concurrent updates on the same node. Relationships, though, are tricky, and we would suggest you start with a single thread. So if you're going to parallelize, then you really need to make sure that your simultaneous merges are against different source and target endpoints. Unwind is something that you'd be familiar with if you've been using Neo4j for a while. We do talk to newbies who've never seen this idiom. Here it is. Please use it. It's kind of obvious that if you were to insert or merge 1,000 records, then repeating this fragment 1,000 times would be inefficient. It would require 1,000 parses, 1,000 plans, and a lot of extra text over the line. So when you're using Unwind, you're basically sending an update template, like a JDBC sort of stored procedure. You're sending that, and then you're sending the data separately, sort of sidecar as an array with that request, and it's much more efficient. Maybe 100. Well, it's going to depend on your data size, how your savings, right? Null values, we've talked about that. There's some nice links here, but be sure to use coalesce. You'll recognize coalesce from Oracle or other relational systems, databases. It's just a scalar function, and you can provide a default value that your application will know how to handle, whether that's empty string or 0 or timestamp or something. Data types is an area where I hit some challenges. It was a little strange to me at first. We don't natively store doubles or decimals, and many of your source systems are going to give you doubles and decimals by default. And you're going to need to cast those to floats before you insert them into Neo4j. The default data type, when you're using some of our API calls to ingest sources, is going to be string. So you're going to want to cast those strings to more specific sources if you want to be querying them as time or local time or Boolean points, duration, or integers or floats in Neo4j. So there are some cool functions in the apoc library, which we'll get to. So check those out. There are some nuances around returning, writing and returning lists and maps, kind of beyond the scope of this presentation, but be sure to check out that manual and check out Matt's code in HOP to see how he, some of the interesting things he does with those data structures. I mentioned apoc. So since like version 3.3, I believe, we've had this incredibly extensive library that was kind of built out of necessity and delight by Michael Unger, now a shared project and supported by Neo4j officially. Mike, of course, works here. He's one of our leading minds and helped pull together NODES2022, just a gem of a guy. Check out his videos on YouTube that talk about the apoc library. It's really terrific. Materially, if you were to build an ETL from scratch without a lot of scaffolding, you'd want to look to apoc for some acceleration functions. So those include the ability to ingest various kinds of text files from cloud sources, loads. You can connect right to JDBC. You just provide the JDBC drivers in our plugins directory. Of course, sort of some shorthand helper scripts for creating and merging, for reaching out to other systems like Elastic, Mongo, other Neo4j databases, LDAP, Redis, and so forth. We'll talk about apoc periodic functions in just a second. Likewise for exporting, some really terrific helper functions, casting and cleanup functions, functions for running many Cypher statements together, and schema introspection, which is a huge deal if you're building some kind of GUI. You want to figure out, what types of nodes and relationships are in the system. To get out all that metadata, because we're a schemaless system, requires something like a select distinct on all of our data smartly in order to derive that metadata. So let us take care of that for you by using those functions. There are some dummy data generation functions that are really neat. There's a handler to NLP. So if you're using one of the public clouds that has a service, this is a really great way to pull in that data and leverage those services. Now, apoc itself is open source. You can create your own libraries of functions as well. That's in Java, and they run in the Neo4j engine. It's really a phenomenal capability used by many customers for many things. And just go apoc help if you want to see more about it. Periodic iterate I bring up separately because it's so commonly used. The thought experiment is pretty simple. You've got an unwind with millions of records. If you send that to Neo4j directly or a source query, you're going to blow up your potentially blow up your transaction limit, which I mentioned as 2 gigs. So you can send these into the Java handler in apoc through apoc, and it's going to create batches of records to insert or update, and it will do a transaction per batch. If that function if the server were to kind of go down in the middle of that operation, you would have some inconsistency vis-a-vis the source. But if it's a merge, you could rerun it and you'd be whole. In Neo4j 4.4, this functionality was added as a Cypher feature, so you don't need apoc periodic iterate in order to get the same effect. Now, that would be relevant if your server did not support or you weren't able to load Java stored procedures, including apoc. There's some core APOC functionality that you'll have even on our hosted offerings, but our hosted offerings don't support your custom procedures. You'll need the classic sort of, if you will, on-prem install for that, which you can install in the public clouds as well, starting with using CloudFormation templates and other scripts that we provide. For a more full review of this topic, you want to check out this link. It's a bit nuanced, but really exciting and almost necessary unless your sort of underlying framework is already doing batching for you, which it might do. I know that with the Apache Beam project I worked on, this was handled in the Beam framework, so I didn't have to deal with it. Quick note about scheduling. There are lots of schedulers out there, so please use them. We don't have a scheduler inside Neo4j, so use cron, Airflow. Every cloud has a scheduler, and then various third parties, whatever you're using. I found this MFT stuff fascinating when I was looking at it last year, so check that out. A note about writing your own cipher. So good, but can be difficult with special characters, quoting, handling injections. As with anything, you can sort of write the SQL yourself, in our case, cipher, or you can use a domain-specific language. We have one for Java, and it generates the cipher for you, and it's thoughtful about how it does that. So check that out. Just some final notes before we wrap up. Obvious stuff. Misspelling a name creates a new label. Misspelling a property creates a new property. Forgetting to specify a label can generate a node with no label. There's a pattern out there. We talked about the orchestration of instead of creating nodes and then relationships, you can sort of refactor relationships as nodes. Basically create a synthetic node with a property source, source node identifier, target node identifier, property, and so forth. That would allow you to very quickly and in parallel put all your relationships into Neo4j, but they're relationships in staging, and until you actually transpose those, transform them into actual relationships, they're not going to be useful to you. It is a pattern, and I haven't got a ton of information about whether it's at the end of the day better. I think it's just a different way of doing it. It will release your ETL sooner, in that you won't be waiting for all the relationships to commit, but you're going to need to kind of wait anyway after the load, if you trigger some kind of post-load transform to do that for you. Remember in your code to handle, when you're working with transactions, handle deadlocks, transaction failures, errors, and runtime exceptions. And I mentioned Python reads are a little slower. Node can have multiple relationships, multiple instances of the same relationship type on different nodes, multiple instances of the same relationship type on the same nodes. These seem a little strange to mention now, but if you're kind of new to Neo4j, this might be interesting to know. That's it. Let me urge you to reach out. We're here for you. There are a lot of benefits in the customer community, a growing huge number of customers and partners when you do create reusable ETL and ELTs. So we see that. We want to help you. And you sole developers out there, enjoy our Neo4j community. It's fantastic, and you can always email me directly as well. So thanks so much.